Bismillahirrahmanirrahim. Assalamu alaikum. Today I'm going to tell you about the two more functions from the apply family. They are lapply and supply. If you compare lapply with supply, the input that you can provide to lapply, that would be a vector, a list, a matrix, a data frame, or an array. And same is the case with supply. So they are identical in this case. However, with respect to output, the lapply could give you a list only, I think, and supply will give you a vector, a list, a matrix, and that depends on the input and the function you use inside the supply function. And the list that you are giving to the lapply or to the supply, that list could contain vectors, matrices, data frames, and even other lists inside the lists. For example, if you are given 3 data frames, that is df1, df2, df3, and you want to use lapply or supply function on these data frames. For example, you want to find out the standard deviations, the variance, the sum, the mean, the square root, etc. of the elements of the data frames of all the 3, then you can use lapply or supply functions on them. You can also put all these 3 data frames into one list, and then that list could be used as an input to the lapply or supply. So how will you put all the 3 data frames into a list? This is the method given here. You just give a name to the container, that is lst here, and then use the function list to enclose all the 3 data frames into that list. Okay, let's see if our input is a vector, then how we'll use these functions. A vector, as I have already explained in one of my videos, is a type of data structures that contain only single kind of data and in a single dimension. For example, here you can see a vector that is stored in a container called V, and there are 6 elements in that vector. They are from 10 to 15. In the case of lapply, if you use, the output will be a list, while in the case of supply, the output could be a vector. Here you have to remember one thing, that is, only those functions inside the lapply or supply function will work on vectors that acts on individual elements of the vector. Supply, for example, here I am using the function sum inside this supply function or in the lapply function. They will not work because sum is a function that takes all these elements inside the vectors and gives a single output. So these type of functions that takes all the elements from the vectors and then gives you a single output, they will not sum all the elements using supply or lapply function. However, other functions like square root, sqrt, because square root takes each element and gives output for each element as the square root of that element, so those functions that take single elements and then gives out a single output, those functions will work on this and they will give you an out. However, if you want to use sum as a function inside the lapply or supply, then you must enclose this vector first into a list using this method, that is lst, for example, is the container in which you are going to store this vector through a function using list. So here I am using the function square root. So using supply, taking the input data structure V, that is the vector, and then using the function square root on this vector. So it will take the square root of each of these elements and will put them in an output vector which is like this. So this is supply. If instead of supply you use lapply function providing the same V and function square root, the structure of the output will be different, that is, it will be in the form of a list. The values will be the same, only this data structure will be different. So if you need your output to be in the form of vector, then use supply, and if you need a list in your output, then you must use lapply function. Now let's talk about if you have a matrix as an input to the apply or supply function. Given here is the matrix, and this matrix has been saved in a container called M. It has 3 columns and 3 rows, as we have already discussed in one of my videos, that matrix is a data structure that has same kind of data, but it has 2 dimensions. For example, this is a matrix M. Here also the same thing, only those functions that takes individual values will work and they will give output, and those functions that take all the elements as their inputs and give one output, they will although work, but their output will be the same like this matrix. They will not give you the sum, for example. For example, if you use supply function on this M and then the square root function, it will take the square root of each element and will result in a vector output. The same result will be an output if you use apply, but the data structure will be different. That is, its output will be list. If you use Dataframe as an input to the supply and apply function, then let's see what will happen. First, what is Dataframe? Dataframe is that matrix only contains single type of data, while Dataframe can contain multiple type of data. For example, this Dataframe has character data in this column A, B, C, and numeric data in these 2 columns. What you have to do, you have to change this into a matrix. Not actually in a matrix, but you just have to remove this column from this data frame. Then you will have to use the supply or apply function, just like you did with matrices. If your input is an array data structure, a type of data structure that contains 3-dimensional data, that is rows, columns, and matrices. So that is called an array. So here in this array, there are 3 matrices. Each matrix has 2 rows and 3 columns in it. If you want to use apply or supply function, first you will have to put this array into a list stored in a variable like LSA using the function list. However, functions like sqrt, they will work on arrays even if you don't put them in a list. So what is a list now? If you give input as a list, this is the actual thing that apply and supply function needs as its input. So a list is a data structure that has only one dimension, just like a vector, but it can contain multiple types of data in it. However, this is a complex thing because it can contain vectors, matrices, data frames, arrays, and even lists inside this list, and even lists inside lists and inside lists in that. So this is a very complex data structure. For example, here in this list called LST, which is stored in LST container, it has 3 elements enclosed in double brackets 1, 2, and 3. Each of these elements is a vector. The first element is a vector and it has 5 elements. This is another vector and this is another vector. This is the syntax for using the apply or supply functions over lists. First, you will have to give a data structure. Usually, we provide list as an input data on the place of this X. And the second argument here in this function and as well as in this function is the func, that is function. Here you will have to use the function like sqrt, sum, mean, a plus symbol, a minus symbol, an asterisk symbol, or any other kind of function here can be provided. These three dots means that these functions might contain arguments inside them. So if you want to use the arguments of the functions provided here, then you will have to put those arguments here. So these dots represents the arguments of these functions. If you want to find out the mean of each element of a list, then you will have to use it like this: lst instead of x, mean in the place of function, apply and supply. Now let's first take a list that contains vectors inside it. For example, this is a list, lst. It contains 3 elements, each of them is a vector itself. If you use the apply function and you want to find out the mean, then you will have to use this syntax and the output will be in the form of a list. However, if you use the supply function, the output will be in the form of a vector. This is the mean of 3. This is the mean of the first element, that is 3. 6 is the mean of the second element, and 4 is the mean of the third element of the input list. However, the same result has been put in a vector format if you use supply function. If you use function sum on this list, then it will take the sum of these elements and will give you an output of 15. Similarly, this is the sum of the second element and this is the sum of third element. Median function, if you use standard deviation and variance. However, if you use the supply function, the output will be in the form of vector. There will be no difference in the output of the apply as well as supply functions. If you use a function that takes individual elements and give you an output, and the number of the output element is equal to the number of the input elements of each element, then there will be no difference in the output of the apply and supply functions. As you can see, apply and supply have resulted in the list. If you provide a list that contains matrices inside it, so this is a list that contains matrices, let's find the mean of each matrix in the given list. That is the mean of all these elements, then the mean of these elements, and then the mean of these elements of the third matrix. So this is your input list. And if you use the apply function on this ls2 container, that is the list, and use the function mean, your output will be like this in the form of a list. And if you used supply, then your output will be in the form of a vector. If you provide an input list that contains mixed data. For example, this list3 contains vector, matrix, and another list inside the list, and this list itself contains two vectors, that is two elements in them. If you use the apply function, your output will be like this. This is the mean of all these elements. This is the mean of all the elements. However, there is an error in the third element. Why? Because this element contains sub-elements, and your function apply cannot access the sub-elements of this third element. Now let's come towards extracting the elements from the elements of a list. You will have to use this function, that is the opening bracket enclosed in inverted commas, to extract elements from the elements of a list. First of all, a single element extraction from a vector. For example, this is a list, and you want to extract a single element from each of these vectors of the list. Then you will have to use function like this, apply lst, this thing, that is opening bracket. It means instead of using sum, square root or other thing that is in the place of function, you will have to use this thing, and this means that I am going to extract element from these vectors of the list. And this 2 means, as I have already told you, that there are 3 dots here. They are the arguments of this function. So 2 means that this is the argument of this function. Here it means that I am going to extract second element from each of these vectors of the list, that is 2, 4 and 3. And if you used a supply function, the procedure is the same like this, but the output will be a vector. Now let's extract a single row from each matrix that contains in a list. Okay, now as we know that matrix has 2 dimensions, so this function will have 2 arguments. First before the comma and second after the comma. If you are going to extract the row, then this is the place. So here we are going to extract row number 2 from each of these matrices. So row number second, and row number 2. And in place of this column, you will have to leave it empty. So the output will be like this. Now let's see how to extract a column. Instead of the opening bracket, you can use other functions like plus, minus, multiplication sign, division sign, and this modulus, and this one quotient to find out the quotient of two numbers. These must be enclosed in inverted commas. For example, this is a list and you want to add 5 to each of these elements of each of the 3 vectors. Then you will have to use the plus sign. It means add 5 to each of these elements. So as you can see, 1 plus 5, 6, 2 plus 5, 7, 3 plus 5, 8, and so on. The output of the apply and supply will be of the same type. If you want to extract multiple rows and multiple columns, then you must enclose them in C function. So here we want to extract row number 1 as well as row number 2 from each of these 3 matrices, as well as we also want to extract only the elements, these rows, from column number 1 and column number 2. Okay, thank you for watching my video. Take care, bye.